And again, if you want to go back to the first page, you just click this symbol here or this small house here. Okay, so introduction to HPC2N, Kebnekaise, and HPC. So HPC2N, it's a competence center for scientific and parallel computing. And it's part of NICE, which is National Academic Infrastructure for Supercomputing in Sweden. And they are, among other things, in charge of the super page, where you apply for project resources at various centers in Sweden. So what is HPC2N? It is short for High Performance Computing Center North. And we have various HPC resources and infrastructure and some large-scale storage facilities. There's a project storage I talked about. There is WLCG storage that is for the very large Hadron Collider down in CERN. They have storage and they're also running grid computations here for we are a tier 1 node for the Nordic for this grid computing for them. We also have tape storage, which is used for backing up home directories and also for backing up home directories from other departments. There is the Swedish Science Cloud, which is a small cloud system that we are part of, that it can be used if you need to run something that cannot be run on a Linux system. And then we are also part of the DDLS, the Data-Driven Life Science in Epidemiology and Biology of Infections. We have some people there working there as well, together with SciLife Lab. We do training and support for our users. And then, of course, we also have a wide range of scientific software applications, libraries, and compilers. And our objective is to raise the national and local level of HPC competence and transfer HPC knowledge and technology to new users in academia and industry. And our focus is northern Sweden. It's hosted by Umeå University, who pays most of the funding for our resources for Kebnekaise. And then we have partners. We have space physics up in Kiruna. There's Luleå Technical University, there's MIT University, and there's SLU. And anyone who are from any one of these places can be a PI for a project at the HPC2N. They can then add anyone as a member of their projects. So as I said, it's funded by Umeå University mainly, and there's some contributions from the other HPC2N partners. We're involved in various projects and collaborations, as you can see here. And as I said, we also do a lot of training and we have other services. We have user support. There are research group meetings. Recently, they have been in the form of the HPC2N FICA, which we will have later this month. I don't remember the date right now. It might be the 16th. I sent out an email about it recently. I will send another one. We will have a short presentation as well at that, and then some information about the new stuff going on at Kebnekaise. And then you can ask questions. So we are trying to do those about once a month.
Yes, Birgitte, it will be September 17.
17.
Yes,
Okay.
at 15:15.
Okay, great. Thank you. So aside from that, we have, of course, regular support. And then we have a great number of different training courses, in many cases together with some of the other centers in Sweden, particularly Uppmax and Lunark, so in Uppsala and Lund, and recently also together with Chalmers in Göteborg. And they are in a large number of areas. So in this fall, the next one up is selecting software modules. That's tomorrow. Then goes the Intro to Linux on the 22nd. And then we will have Introduction to Run R, Julia, and MATLAB in HPC. That course, those two here are still open for registrations. Then there'll be a course together with Uppmax on running and building Singularity and Aptainer containers. That is, Pedro is involved with that. Then we repeat the Linux intro, which has changed name here because we are changing the format of it. Then there's Intro to Git and a repeat of the software modules course. And then we will look more into using Python in high performance computing. Some information about Slurm and batch systems, and then an intermediate Linux course. And you can always find an updated list here. Then there is the HPC2N personnel. I'm not going to cover that really, but you can look at the list if you want to. It just shows who is the management and some application experts we have, which are those you see for support. And then some other personnel. And there's a list also of the system and support personnel. The ones I put in bold were just those who also are application experts. And you will mainly be talking to these people here. And these will be contacting you if there is something more hardware oriented. And here, a short list of which areas the application experts mainly cover. So, HPC2N users by discipline. We have people from many different disciplines, mainly science, as bioscience and medicine, chemistry, computing science and engineering, material science, mathematics and statistics, physics and space physics. And in all areas and others, we have more and more using machine learning and deep learning and other AI. We do not have a lot of users from the other departments, though we are trying to tell them about our existence. So the largest users are the ones in bold. And this is an example of usage at Kebnekaise. This is from last year. And you can see here that Python is a huge chunk. And also programs like VASP or GROMACS. And Julia is now also visible. MATLAB and things like this. What is listed as unclassified is mainly people who are running their own code or material or programs they have installed themselves. So, Pedro.
Yes, I did this plot a few months ago, and something that I noticed is that Julia is extensively used. So the usage increased
Okay.
considerably. Yeah.
Yeah, I think we noticed that over the years that it increases a bit every year, so it is becoming more popular. Yes. I will update this for next time we run the course. So, Kebnekaise, our supercomputer at HPC2N. It's very heterogeneous. It's named for a massive, some of Sweden's highest mountain peaks are there. It's in northern Sweden. And originally we got it in 2016, but there are very little left of the hardware from then because we have extended it many times since then and replaced the old nodes with newer ones. And the plan in general is that Kebnekaise is continuously upgraded as the old hardware gets retired. Right now, let's look at that maybe to see what is here. We have some CPU only, GPU enabled, and some large memory nodes. We still have these Skylake nodes. We are keeping them for now, but they will slowly be retired when we get newer CPU nodes. And then we have some Zen 3 and Zen 4 new CPU nodes from AMD. The GPU-enabled nodes are, there are still some V100s, but mostly we have, well, I guess it's L40Ss that we have most of, but otherwise, as you can see here, there is a great many different types of GPUs. It shouldn't matter much. You can run on all of them, and it mainly matters if you're doing something like benchmarking or something where you really need it to be a specific GPU, and then it's possible to send it to that or to a specific CPU for reproducibility and things like this. So that is, of course, possible, and I'll talk about that on the batch systems. Then there is the large memory nodes. These are fairly old, but they have a lot of memory and they are still being used because of that. So we are keeping those also for now. So GPUs, there are different types of cores on them, as you have no doubt seen. There are the CUDA cores, which are general purpose cores for various parallel computing tasks. They will not be as efficient as the specialized cores if you have something that can run on those. And it's only on NVIDIA. On AMD, you have something called stream processors, which are mostly equivalent. Then you have tensor cores, and they are for matrix multiplications, and they're also good for deep learning and AI workloads with large matrix operations. Can be used for general purpose as well, but it's not as efficient for that. That's what they call them at NVIDIA, the tensor cores. AMD has something that resembles it that's called matrix cores. Then also a small number of our GPUs have ray tracing cores that are optimized for things like ray tracing, like rendering images or videos. You can see a comparison here, how many of the different types of cores are on the different types of GPUs. But just like you can't compare CPUs exactly, you also can't compare CUDA tensor ray tracing cores exactly because newer ones will have more efficient design and be faster, etc. So even if there are fewer, it might be faster. Though there are generally also more of them on the newer ones. So storage, HPC2N has the home directory. That's where you end up when you just log in, or if you go to the location pointed to by the environment variable $home. There's project storage, which is where I logged in here or changed to, and here you can see finally it had downloaded the exercises tarball. There is also local scratch space that will be on each of the nodes and can only be accessed while you are running on that node. And then is the tape storage I mentioned, and we have also the various nodes, storage nodes that we are using for VLCG and other things. So projects. To use Kebnekaise, you must be a member of a compute project. It's not enough to be a member of a storage project. A compute project will have a certain number of core hours for each month, And a regular CPU is costing 1 core hour per hour. GPUs more, and cost is just cost in the allocation. It's not a monetary cost. It's not a hard limit, but projects that go over allocation will get lower priority until other projects have used more, and then they have lower priority. As I mentioned, you have to be, or rather the PI have to be affiliated with one of these universities. You apply for project in Super, just like for the other resources in Sweden. And that is something I will cover in a little bit more detail when we go into HPC2N and Kebnekaise. So what's HPC? I will not be talking much about this section because I think you either know these things or may not be interested. But it's high performance computing, and it generally refers to the practice of aggregating computing power in ways that deliver much higher performance than you would get in a typical desktop computer or workstation, and in order to solve large problems in science, engineering, or business. That is a definition that comes from this place here. So, what is HPC? Well, there is much computing power in general. We have 95 nodes, but they have quite a lot of CPU cores, and we have 84 GPUs with a lot of CUDA, tensor, and ray tracing cores. There is also a very small number of AMD GPUs for testing things on. And you would compare that to maybe you will have 4 or 8 cores in a laptop, or maybe more, and you may have a GPU in it. So there's a lot more computing power. And there is about 527 trillion or billion, depending on if you are talking American or European, I guess, numbers in the CPU cores. And that could be compared to maybe 200 milliard or billion flops in a modern laptop. What is in parentheses is what you would probably say in the Nordic countries, or maybe also in the rest of Europe. Americans will call milliard, billion. I think they don't have the word million. I'm not sure. So when is a problem large enough for HPC? And other reasons for using HPC, I mean other reasons. There's memory, software support, etc. It can be large for two reasons. There is execution time, it could be long, or it needs maybe lots of memory or storage. If it takes a long time, maybe you can fix it by throwing more cores or GPUs after it, or otherwise by using nodes with more memory on it. And we have quite a lot of memory on many of our nodes. So in general, the more memory or storage or the more performance will be HPC. So supercomputers and small computing clusters are HPC. High-end workstations and laptops in general are not. Though, of course, you can do HPC on them. Other reasons to use it? Well, there could be specialized expensive hardware, like GPUs that are optimized for AI, or high-end CPUs that are error-correcting memory. And error-correcting memory, sorry. In addition, HPC2N has licenses for different types of software, and it's already pre-configured and ready to use. So that is a thing that makes things more easy. We also have documentation for many of the softwares we have, and we also have support where you can ask as well. And documentation is at this location here, docs.hpc2n.umu.se. And if you scroll down here, you have the software section. And here are a list of the various software available. There will be some external info, and you can click here and get local documentation as well of the various software we have. It's not exhaustive. We have some software that's not listed here, but we are working on putting documentation of as much of it as possible. And I think I am going to skip the memory modules section. And let's see if there's anything more I will talk about, because I'm a little bit behind in time. I think I'm not going to talk about this. I think I'm just going to move directly to projects and accounts.